Hello students, welcome to my YouTube channel PKM classes. We study about the properties of determinants. In previous classes, we know what is determinant, how it is formed. Now, we study the properties of determinants. Generally, in two matrices, we can add it, subtract it, and multiply it. But in case of determinant, we cannot add it to determinant, or we cannot divide to determinant, or we cannot subtract to determinant, but we can multiply. Now, in this class, today, we study about the properties of determinant. Property number 1. Properties of determinant. Properties of determinant. Property 1. Property 1. In determinant, in any order determinant, second order or third order or any order, if rows and columns are interchanged, then the value of determinant remains same. So the value of determinant is unaltered if rows and columns are interchanged. If rows are written as columns or columns are written as rows, then the value of determinant is same. The value of the determinant, the value of a determinant, the value of a determinant is unaltered if rows and columns are interchanged. In case of determinant, if rows are written as columns or columns are written as rows, then it does not affect the value of determinant, whether it is a second order or a third order. If a determinant is ABCD, then the value of the determinant is equal to AD minus BC. If you change rows as columns or columns as rows, then determinant is equal to ABCD. Here, row 1 is written as column 1, row 2 is written as column 2. Now find the value is equal to AD minus BC. If AD minus BC would represent delta, so AD minus BC is equal to delta. Now the value of determinant remains same or is unaltered if rows and columns are interchanged. So we know that in a determinant, whether it is a second order or a third order, in case of third order determinant, suppose a determinant is A1, B1, C1, A2, B2, C2, A3, B3, C3. Suppose the value of determinant is delta C. If you write row 1 as column 1, A1, B1, C1, row 2 as column 2, A2, B2, C2, row 3 as column 3. Here, in this determinant, we changed rows as columns and columns as rows. We interchanged rows and columns. Now the value also delta. If rows and columns are interchanged any determinant, then the value remains same. Next, property 2. In any determinant, if all the elements are 0, then the value of the determinant is 0. In any other determinant, if all the elements of any row or column are vanishes, the determinant is vanishes. Here, all the elements of row 1 are 0, then the value of determinant is 0. Now column 1 is vanishes, all the elements of column 1 are 0, so the value of determinant is 0. If all the elements of any row or column of any determinant are vanishes, so the value of determinant is 0. Next, property 3. If any two rows or columns of any determinant are equal or identical, then the value of determinant is 0. If any two rows, suppose first row is A1, B1, C1, second row is A1, B1, C1, A3, B3, C3. Here, the row 1 is equal to column 1. If any two rows are equal, the value of determinant is 0. If we expand the determinant, we have A1 into B1 C3 minus B3 C1 minus B1 into A1 C3 minus A3 C1 plus C1 into A1 B3 minus A3 B1, or that is equal to A1 B1 C3 minus A1 C1 B3 minus A1 B1 C3 plus B1 C1 A3 plus A1 C1 B3 minus C1 B1 A3. Now here A1 B1 C3, now A1 B1 C3 cancel, A1 C1 B3 and A1 C1 B3 plus B1 C1 C3, B1 C1 A3. So the value of determinant is 0. If any two rows or any two columns, suppose in a determinant 2, 2, 2, 3, 4, 5, 2, 2. Here a third determinant, column 1 is equal to column 3. If we expand the determinant, the value of determinant is 0. If any two rows or any two columns, are equal, the determinant is 0. Or also proportional. If any two rows or any two columns either equal or proportional. Suppose the row 1 is equal to 4, 8, 10 and this is equal to 8, 16, 20 and 1 minus 1, 2. Here you observe that a row 1 and a row 2 are proportional. 4 by 8, 1 by 2, 8 by 16, 1 by 2, 10 by 20, 1 by 2. Same the value of determinant is 0. Or otherwise, if you take a factor, common factor from row 3, now we observe 2 is a factor, 2 is taken as common, 4, 8, 10 and 4, 8, 10, 1 minus 1, 2. Here you observe that two rows are equal. Row 1 and row 2 are equal, then the value of determinant is 0. Hence the property says, if any two rows are proportional, then the value of determinant is 0. Next, property 4. If you multiply all the elements of any row or column, then the value of determinant is multiplied by that factor. If a determinant, suppose a determinant is A1, B1, C1, A2, B2, C2 and A3, B3, C3. Suppose the value of determinant is delta Z. And we multiply a non-zero scalar from to row 1, K A1, K B1, K C1, A2, B2, C2, A3, B3, C3. Then the value is multiplied by K. If all the elements of any row or any column are increased or decreased by a non-zero scalar, then the value of the determinant is increased or decreased by that scalar. If all the elements of any row are multiplied by a constant, then the value is also multiplied by that constant. suppose a determinant of second order is equal to 2, 3 and 4, 5. Now the value of determinant is 10 minus 12 minus 2. Now we increased row 1 2 times, that is equal to 4, 6 and 4, 5. In this determinant we multiply 2, all the elements of row 1. Now observe the value is equal to 4 into 5, 20 minus 6 into 4, 24. That is your minus 4. When you multiply row 1 by 3, now the value is multiplied by 2. Now multiply all elements by 2. All elements of row 1 is multiplied by 2. Now we observe the value is also multiplied by 2. If we multiply all the elements of row 1, all the elements of row 1 by 2, 4, 6 and row 3 is 3, 12, 15. Now multiply row 1 by 2 and row 2 by 3. Now observe the value is equal to 4 into 15, 60, 12 into 6, 72 minus 12. That is equal to 2 into 3, 6 times. Row 1 is increased by 2, so the value is increased by 2. Row 2 is increased by 3, the value is also increased by 3. Now, if all elements of a row or column is multiplied by any scalar or any constant, the value is also multiplied by that constant. Suppose the determinant is A1, B1, C1 and A2, B2, C2, A3, B3, C3, the value of determinant, let this is equal to delta C. Let this is value is equal to delta C. We multiply K, row 1, K, A1, K, B1, K, C1, K, A2, K, B2, K, C2, K, A3, K, B3, K, C3. Now we multiply all the elements of row 1 by K, row 2 by K, row 3 by K. Then the value is multiplied KQ times, that is equal to KQ delta. Now we multiply row 1 by K, row 2 by K, row 3 by K. Then the value is multiplied by K into K into K, KQ times. Next property. If any two rows or columns, any two adjacent rows or columns of any determinant are intersected, then the absolute value remains same, but sign is changed. Suppose the determinant is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. Suppose the value is equal to delta. If any two adjacent rows are intersected, suppose we changed row 1 to row 2 and row 2 to row 1. If we change any two rows, row 1 row 2 or row 1 row 3, row 2 row 3 or row 3 row 1, if we change any two rows, that is equal to row 1, in place of row 1 we write A2, B2, C2 and row 2 we write A1, B1, C1, row 3, A3, B3, C3. Here, the absolute value remains same, but sign is changed. Suppose a third determinant value is equal to 100. If you change two rows, then value is equal to minus 100. If this is equal to minus 100, so this is equal to plus 100. So absolute value remains same, but sign is changed. Similarly, if you change any two columns, if you change column 1 to column 3 and column 3 to column 1, if you change column 1 to column 3, column 3 to column 1, now C1, C2, C3, B1, B2, B3, A1, A2, A3, then the value is equal to minus delta. Minus delta. If any two rows or any two columns, any two adjacent rows or columns of any determinant are intersected, then absolute value remains same, but sign is changed. Next, if all the elements of any row or column, if all the elements of any row or column consist of two or more terms, then the determinant is expanded as two or more determinants. Suppose a determinant is equal to L1 plus M1, L2 plus M2, and B1, B2. Here, the elements of column 1 consist of two terms. Then the determinant is expanded as two determinants L1, L2, B1, B2 plus M1, M2, B1, B2. Now let us have an example. Suppose the determinant is equal to 2 plus 3, 1 plus 2, 4, 5. Now the value is equal to 3 plus 2, 5, 2 plus 1, 3, 4, 5. Now we know the value is equal to 5 into 5, 25 minus 12. That is equal to 13. Now this determinant is expanded as two determinants 2, 1, 4, 5 plus 3, 2, 4, 5. And the value is equal to 10 minus 4 plus 15 minus 8. That is equal to 6 plus 6 plus 7. That is equal to 13. So the value is same. Now if all the elements of any row or column consist of two or more terms, then the determinant is expanded as two or more determinants. If all the elements of any row or column consist of two or more terms, then the determinant is also expanded as two or more determinants. Suppose as for example, a determinant is A1, B1, C1, A2, B2, C2, A3, B3, C3. Suppose the value is equal to delta. And this A1 is written as L1 plus M1 plus N1, L2 plus M2 plus N2, and L3 plus M3 plus N3, B1, B2, B3, C1, C2, C3. Now all the elements of column n consist of three terms. Is expressed as consist of three terms. Sum of three terms. Now the determinant is expansion of three determinants. Now this determinant is also sum of three determinants L1, L2, L3, B1, B2, B3, C1, C2, C3 plus M1, M2, M3, B1, B2, B3, C1, C2, C3 plus N1, N2, N3, B1, B2, B3, C1, C2, C3. Now all the elements of column 1 consist of or sum of three terms. The determinant is also expressed as sum of three determinants. Next we study the last property, that is most important property. If all the elements of any row or column of any determinant, if all the elements of any row or column of any determinant, either second order or third order or any other, if all the elements of any row or column is, if all the elements of any row or column is increased or decreased by corresponding rows or columns with equal multiples, then the value of determinant remains same. If all the elements of any row or column is increased or decreased by corresponding rows or corresponding columns with equal multiples, then the value of determinant remains same. Now let determinant third order. This is equal to value is equal to delta. Now write C1 is equal to C1 plus m times of C2 plus n times of 3. Now we increase column 1 by n times of column 2 and n times of column 3. Column 1 is increased. Now in place of column 1 we write A1, A2, A3 plus m times of column 2 MB1, MB2, MB3 plus NC1, NC2, NC3 B1, B2, B3, C1, C2, C3. Now here we increase column 1 by n times of column 2 and n times of column 3. Now in previous rule we know that if a determinant consists of 3 terms, it is expressed as sum of 3 determinants, that is A1, A2, A3, B1, B2, B3, C1, C2, C3 plus MB1, MB2, MB3, B1, B2, B3, C1, C2, C3, C1, C2, C3 plus NC1, NC2, NC3, B1, B2, B3, C1, C2, C3. Now we observe here column 1 and column 2 are proportional, or we take M as a vector. So row column 1 is equal to column 2, so this value is equal to 0. And this is the value of determinant is equal to delta. We take the value is equal to delta. We take M is a common, B1, B2, B3, B1, B2, B3, C1, C2, C3, N as a vector, C1, C2, C3, B1, B2, B3, C1, C2, C3. Now you observe the values of delta M into 0 plus N into 0. This is equal to delta. Now the value remains same. The value remains same. Our value is unaltered. If you increased any column which is corresponding columns, any times if you added a column which is corresponding columns by any multiples, then the value remains same. So if all the elements of any row, similarly if you added row 1 to row 2 or row 3 any times, the value remains same. So the value is unaltered. If rows are increased or decreased, suppose we decrease m times, if we decrease m times and decrease n times, this is equal to minus. So this is equal to minus, 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 minus. So minus as a vector. So this is equal to also 0. Now if all the elements of any row or column is increased or decreased by corresponding rows or corresponding columns, column by columns or row by rows, then the value determinant is unaltered. The value of determinant remains same. So we now study the properties of determinants. In next classes, we start some examples of determinants. Thanks to all.